Hi. So today we are going to work on tangent and cotangent and graphing transformations of those equations. So what you need to do first is let's go to your tangent and cotangent parent graphs. They're on page 5 and page 6. Okay, so let's look at page 5 with the tangent parent graph. So this is how 2 cycles of this is graphed. So some students, every year I see this, when I ask somebody to graph a cycle, they will graph this entire graph. Okay, remember the definition of the period is the graph without repetition. Well, this repeats this. So just a reminder that the period on the parent graph is pi, and after pi we start repeating. The amplitude is infinity, but something else that we have to look at. We know that tangent range, the range is from negative infinity to infinity. However, also though, we can see that at values like pi over 4 and 3 pi over 4, etc., we have 1 there. So you're going to hear me refer to those as key points. Okay, so also understanding that tangent, we have to always know what's happening at 0. Just like we know that sine of x is 0 at 0 and that cosine of x starts at 0a. Well, tangent is 0 at 0. So what are the 2 options we have if I ask you to just graph one cycle? Okay, so we know that the period would be pi, and then just like always, we take our period and divide by 4 to get the x scale, so that we have at least 4 points including asymptotes, Okay, so I could go from 0 to pi, and again, my period would be pi over 4, so I would divide by 4, so my scale is pi over 4. So I'm counting by 45s. So at 0, I'm at 0. At pi over 4, I'm at 1. And at pi over 2, asymptote. And then at 3 pi over 4, I'm at negative 1. And at pi, I'm back at 0. That's an example of one cycle. Now, there's another way to do this. Some people don't like that you have 2 broken curves here. So another way to graph one cycle is to graph one complete curve, but half of it on the negative side. So if my period is pi, and if I divide by 4 to get my x scale, this would be pi over 4 and then pi over 2. But then over here I would have negative pi over 4 and negative pi over 2. So tangent is 0 at 0. It is pi over 4, 1, and an asymptote at pi over 2. At negative pi over 4, it's at negative 1, and at negative pi over 2, it is undefined, so you have an asymptote. So I encourage you to choose whichever way you want to do, but I wanted to be clear that this is one cycle. All right, just like with sine and cosine, I will be asking you to graph 2 cycles of the transformed equations, but I want you to make sure you understand that this is one cycle. Okay, you have either choice. You could graph 2 cycles like this, or you could graph another cycle over here. Okay, so now what I want you to do is take out your calculator, and we are going to look for patterns. So this is some of your notes, and so what I'm going to need you to do is I'm going to have you turn to page 18. So take a look in your packet, or if you don't have a packet, if you are my remote section, then you will want to pull up page 18, and I want you to do problems 1 through 8 on your calculator. And the idea is you are looking for patterns, okay? So again, like with sine and cosine, we're looking for patterns on how this compares to the parent graph. So we're gonna make changes to the equation, and I want you to see how it compares to the parent graph. So look at the directions at the top of page 18 about how to set up your calculator. You wanna be in radian mode. We are going to graph one cycle. So again, look on what the directions are, and then look for key points, okay? Look what's going on at 0. Look how the graph vertically changed and horizontally changed. So please stop the video and do page 18, 1 through 8. We know the amplitude's always going to be infinity, but we know that we have key points. In other words, like in the parent graph at pi over 4, I was at 1. All right, look to see how the graph changes. Okay, so hopefully now you are back, and we know that if I have the equation y equals a tan of bx, a stands for the amplitude, and we know it's always infinity because there is no distance from the horizontal axis to a point because there's no high point or low point. However, we know that the graph will vertically stretch or shrink by plus or minus a. Period is not 2 pi over b, it is now pi over b, since we know that the period of the parent graph is pi. Okay, now let's go back to page 6, and again, at any time if you have to stop the video, do so. Let's go back to page 6 and look at our parent graph y equals cotangent of x. Okay, so again, I want to emphasize, we have 2 cycles showing on page 6. Okay, so if I look, between 0 and pi is 1 cycle, between pi and 2 pi is another cycle. So the period of my cotangent graph is pi, and we know that we have an amplitude of infinity, but if you look, you also have key points where the graph changes direction at 1 and -1. Now, I want you to compare, and this is why the other day I had you graph tangent and cotangent together. I want you to compare cotangent to tangent. Cotangent is a reflection of tangent, but it is also horizontally shifted by pi over 2. The key is understanding, once again, what is happening with cotangent, where it begins. And cotangent is undefined at 0, so you will have an asymptote. So again, tangent starts at 0, if you want to look at it that way. Cotangent is undefined. All right, so my apologies for this once again, but I want you to go back to page 18, and we're going to do some more discovery and looking for patterns. So if you need to stop this, go ahead and stop this, go back to page 18, and we're going to look for patterns using your calculator. Now, you'll have to adjust your calculator. You're going to be doing the rest of page 18, but how you'll have to adjust your calculator is you'll have to make your x min 0 and your x max pi, and then the rest should be fine. All right, and I want to reiterate, this would be an example of 1 cycle of cotangent. It's undefined at 0, undefined at pi. It has a key point at pi over 4 at 1. It's 0 at 0, and a key point at 3 pi over 4 -1. So in other words, if I took the cotangent of 0, it would be undefined because that would be 1 over 0. If I took the cotangent of pi, it would be undefined because that would be -1 over 0. Okay, so on page 18, I want you to do 9 through 16. So go ahead, turn off the video, stop the video, and do 9 through 16 and look for your patterns. Look for how the period changed, look for how your key points changed, and come up with a solution or a generalization. Okay, so if you are back from doing page 18, when we have y equals a cotangent of bx, we know the amplitude is technically plus or minus infinity, but we know we have key points at plus or minus a, and again, the period can be found by taking pi over b. Okay, so now if you want to take out graph paper, you can use the template that I've attached, or you can just sketch these on a piece of notebook paper. All right, but we are going to do 4 examples, or 3 examples. We are going to graph now changes of tangent and cotangent with changes in their equation. Okay, so the first example, so again, if you need to get out a piece of paper and sketch this, all right, we are going to graph y equals 3 tangent of 1/2 x. We're going to graph 2 cycles, but we do this as the same approach as we did with sine and cosine. Okay, we're going to find the period, we're going to find the x scale, and we're going to find the amplitude, or in this case, key points. So my period would be pi over b, so in this case that would be 2 pi, and just like before, you're going to take your period and divide by 4 because you need 4 angles in addition to 0 to get a complete graph. So my x scale is 90, or I'm going to be counting by pi over 2. My asymptotes are my amplitude is infinity. We should always write that, I didn't write that, but I will have key points at plus or minus 3. Okay, so to get started, I'm going to, first of all, what I like to do with tangent is probably the exception. I personally like to graph it where I have two full curves. Okay, so what I would do when I'm labeling my x-axis is I would graph one cycle first. So I'm still going to be counting by pi over 2s or 90s. So I'm going to do pi over 2 and then count by pi. And then I'm going to go to negative pi over 2 and then to negative pi. I know I will have asymptotes at pi and negative pi. And this will be vertically stretched at 3 and negative 3. Now, that's one cycle. So now all I have to continue to do is graph another cycle, which means if I'm going to go from pi to 2 pi here, or I'm going to count by pi over 2. All right, so I would have 180 plus 90 is 3 pi over 2. 270 plus 90 is 360 or 2 pi. I have to go bigger than 2 pi. So I would have 2 pi plus pi over 2 is 5 pi over 2. And then 5 pi over 2 plus pi over 2 is 3 pi. So between here and here, I have asymptotes. And again, my middle value, I have 0. My value up here, I have 3. And my value down here, I have negative 3. Again, this is from knowing the parent graph. All right, so how do I know that I had the correct length? Well, here's one cycle, and that is 2 pi long. Here's another cycle, pi to 3 pi, and that is 2 pi long. That is 2 cycles. Now, I did not sketch in the parent graph, but we know that this is vertically stretched by 3. It would be 3 times as tall, but it is definitely horizontally stretched because the normal graph would have one cycle between negative pi over 2 and pi over 2. So how do I express the horizontally stretched? Well, I could say 2 parent graphs fit into one cycle here. Think about one cycle of the parent graph is pi, and so this is 2 pi, so I could fit 2 parent graphs in there. Okay, next example. Y equals negative tangent of 3x. Okay, so again, if you want to draw your x and y axes, and we're going to describe our changes, and then we're going to graph. All right, so a negative, just like always before, a negative means reflections. This is why we've talked about transformations. Okay, I'm going to find my period. It's going to be pi over 3. And if you think about period is a horizontal shrink or stretch. And if you remember, when a number was inside of the function, it affected it horizontally. If a number was outside, it vertically stretched or shrunk it. No change from any polynomial function we've known, absolute value function. Those transformations stay the same. The only difference is we call them a change in period and amplitude instead of vertical stretch and shrink and horizontal stretch and shrink. Okay, so now my period is pi over 3, which think about this in terms of degrees. That means that I'm going to have one cycle in 60 degrees. So that's definitely horizontally shrunk. Now I'm going to do the same thing. I'm going to take my period and divide by 4. So my x scale is pi over 12. Now, I went ahead, and if I were you, I would think of and kind of going back and forth between degrees and radians. Pi over 12 is how many degrees? Well, if I take pi over 12 and multiply it by 180 over pi, I'm counting by 15 degrees. Okay, so here we go. Tangent. Again, the only exception, I'm going to graph part of it on the negative side. We're going to graph 2 cycles, but with tangent, I go ahead and graph one cycle and then graph the next cycle separately. So I'm counting by pi over 12. So this would be pi over 12. Pi over 12 plus pi over 12 is pi over 6, or if you think about it, 15 degrees plus 15 degrees is 30 degrees. Pi over 6 is 30 degrees. Then I'm going to come over here. This would be a negative pi over 12. This would be a negative pi over 6. Okay, so now we got to know what tangent does. At 0, it is at 0. Now, normally it would be here. At pi over 12, I'd be at 1, but it's reflected. So at negative pi over 12, I'm at 1, and at pi over 12, I'm at negative 1. Think about why this works. If this is 30 degrees and this is 30 degrees, that's 60 degrees, and we know that that's period is pi over 3. Okay, now let's graph the next cycle. So again, we always need 4 angles. We need 3 angles between our asymptotes. So we're still counting the same approach as we've always used by our pi over 12. So if we have 30 plus 15, that's 45, which is pi over 4. Okay, I've got to take 45 plus 15, which is pi over 3, or 60. Now I've got to take 60 plus 15. 75 isn't common, but if I'm going to add pi over 12 to pi over 3, isn't that 4 pi over 12 plus pi over 12. So that's 5 pi over 12, which is 70 degrees. 75, I'm sorry. 75 plus 15 is 6 pi over 12 or pi over 2. So here's an asymptote, here's an asymptote. My middle angle, I'm at 0. My first angle, I'm up at 1. My second angle, I'm at -1 because it is reflected. So this is a horizontal shrink. All right, how would we describe it? All right, if I complete a cycle in 60 degrees, that means that that's a third of the parent graph. So a third of a parent graph could fit into one cycle. No vertically shrinking or stretching. Okay, so let's do one more. Let's do one with cotangent. So we have y equals 4 cotangent of 2x. All right, so my period is going to be pi over 2, so that is a horizontal shrink. Again, a number inside multiplying changes it horizontally, so that is a horizontal shrink. All right, I'm going to take pi over 2 and divide by 4. That's pi over 8, so my x scale is pi over 8. Again, when you have not common angles, I would encourage you to figure out what degree that is because that's going to help you label your x-axis and know what you're counting by. All right, I will have key points at plus or minus 4, which means I will have a vertical stretch by 4. And that makes sense. If I'm multiplying a number on the outside, that's a vertical stretch or shrink. Okay, so now cotangent is like sine and cosine in that we start at 0 and we can graph 2 cycles between 0 and whatever the length of our 2 cycles would be. Okay, so I know that this is a period of pi over 2. So kind of like tangent though, I sketch one cycle and then I go to the other. So between 0 and pi over 2, I will have one cycle. So I'm going to be counting by pi over 8. Pi over 8 is 22.5 degrees. So pi over 8 plus pi over 8 is pi over 4, or 22.5 plus 22.5 is 45 degrees. Okay, pi over 4 plus pi over 8, that's 2 pi over 8, plus pi over 8 is 3 pi over 8, which would technically be what? 67.5 degrees. 3 pi over 8 plus pi over 8 is 4 pi over 8 and pi over 2. Now we got to know what's going on at 0. At 0, I will have an asymptote, and at pi over 2, I will have an asymptote. I know my middle angle is always 0, and then my first angle, I would be up at 4, and my second angle, I would be down at -4. Remember, this is cotangent. Cotangent is part of the difference between tangent is that it's reflected. So this isn't reflected, but just helping you remember that tangent and cotangent are reflections of each other as well. Okay, so now graphing the next cycle. All right, so I've got to count by 22.5 or pi over 8. So this would be pi over 2, which would be 4 pi over 8 plus pi over 8 is 5 pi over 8. 5 pi over 8 plus pi over 8 is 6 pi over 8, or 3 pi over 4, or 135 degrees. 3 pi over 4 plus, that would be 6 pi over 8 plus pi over 8 is 7 pi over 8. 7 pi over 8 plus pi over 8 is pi. So between pi over 2 and pi, I would have another cycle. So I would have an asymptote at pi. My middle angle is 0. This angle is up at 4, and this one is down at -4. Okay, so for tangent and cotangent, I always graph one cycle first and then continue with the second cycle. All right, this is vertically stretched. It's 4 times as tall. It is horizontally shrunk because the period is pi over 2 instead of pi. So if we think about the parent graph, we could actually fit one cycle between 0 and pi. So half of a parent graph would fit into here. So if I were graphing my parent graph, if you look how I trace this, my parent graph would go all the way between 0 and pi. Okay, so the difference between tangent and cotangent, we know tangent starts at 0, 0, 0, and cotangent has an asymptote at 0. The difference with tangent and cotangent versus sine and cosine, I would graph one cycle between your asymptotes and then go to graph the other cycle. If you get angles that aren't common with the x scale, convert them to degrees. That will help you count or add to get to your next angles. All right.